Let's have a quick look at Find Marine Sail Wizard mode. The main goal is to provide a complete CFD workflow for marine-oriented simulations, and it is very simple to use. The user inputs the geometry, defining the flow, operating conditions, mesh setup, and additional numerical models if needed. And the outcome is a complete project with the entire CFD workflow ready to run. Okay, so Wizard sets up the entire CFD workflow from meshing to simulation, but what is happening in the background? The domain, meshing, and simulation settings are based on our best practices, users and developers' experience, and it is not a black box. The user can check all of the settings and even modify them. Sail Wizard also contains a very nice hydrostat calculator, and this is actually quite nice. For instance, let's consider a case that the user does not know the displacement or the center of gravity or the inertial matrix of a given vessel. It can be all calculated if you provide a draft. Sail Wizard is also available in batch, which is great for optimization projects. And finally, it can be coupled with our Rhino plugin. If you are using Rhino, you should really have a look at this mode. As you can see on the right side of the slide, there are 8 applications implemented in Sail Wizard: resistance, seakeeping, propeller open water, planing regime, sailing yacht velocity prediction program, hydrofoil, trim optimization, and PMM maneuver.
For realistic simulations, you often will want to have flexible body motions. A good example here is the KCS in a zigzag maneuver with an accurate rudder model. When it comes to accuracy, in general in CFD you will want to have a fine mesh where you have relevant flow features or strong gradients. As an example here, we have a 2D airfoil simulation under various angles of attack, and we see the adaptive grid refinement triggering the creation of new mesh cells as the gradient changes.
When you find yourself in a situation where you want to take the propeller effect in account, but you don't have the propeller geometry, you can use the actuator disk model. A common application is the propulsion simulation, where we basically have a resistance setup and we add on top the actuator disk model, which will increase the computational effort by a small amount, but in return, we can access propulsion information such as thrust reduction and even wake fraction. And the usage of an actuator disk is not limited by propulsion simulations. Anytime you want to include the propeller hull interaction with a low-cost approach, you can use it. Some examples are trim optimization, seakeeping, and maneuvering. In this video, for instance, you can see a complex simulation including wave generation, a rudder controller which is based on the ship motion, and the ship in an overset mesh. And just that you know, all the degrees of freedom are solved. And sure, one could add the propeller in a sliding grid, but it would impact not only the amount of cells in the mesh, but also the time step requirement for this simulation. Therefore, this is a very good example where an actuator disk makes a lot of sense to be used. Even if you have the propeller geometry, you need to think which propulsion modeling you want to use in your simulation. In Find Marine, we can tackle propulsion with 3 different methods. On the left side, you see the drag-based range, which is a very simple mode that impacts the boat kinematics with no additional computational effort. One application I can think of is on the small pleasure boats, where the comfort is of a big importance, and this mode will provide you information that the pier resistance will not. Then we have the actuator disk, which is a big jump in accuracy compared to the drag-based range, and we start getting very useful information of the propeller hull interactions, and as I mentioned before, the additional computation effort is minor. And finally, on the right side, we have the unsteady simulation of a propeller sitting on a sliding grid, where we're gonna get the full propeller hull interaction. In this case, it will require an additional domain with the presence of the propeller, and the computation effort will be much larger. In this life hack, we will only concentrate on actuator disk. One of the simplest and cheapest ways to improve the performance of a vessel is via the so-called trim optimization. And the idea is to distribute the cargo and ballast to find an optimal trim to decrease the delivered power. In this kind of analysis, it is also important to indicate the trim values that the captain should avoid. And what are our options if you want to perform a trim optimization? We can go to a model basing, we can use the operating points of the vessel. This option is a bit more tricky and I would say less accurate. And finally, we can use numerical simulation or CFD simulation. And that's what I want to share with you today. You're gonna learn how to set up a trim optimization project, creating multiple simulations with the help of our Fine Marine Sail Wizard Matrix mode.